All right, this screencast is going to be for graphing linear inequalities on the coordinate plane. So the first thing we want to do is treat the inequality that we're given just like it was an equation of a line, but we need to look at the symbol and determine if our line is going to be solid or dashed. So here we have greater than or equal to, so that means we're going to have a solid line. And we want to start at positive 1. So our b value is positive 1 and our slope is 2 over 1. So we want to start at positive 1 and then go up 1 and forward 2. Up 2 and forward 1. Up 2, forward 1. And then make the same kind of backwards movements. So we get lots of points. And then we decided we're going to have a solid line because of the inequality symbol. So we're going to go ahead and connect all the dots with a solid line. And then we need to pick a point to test. The origin is not on the line, so that's an excellent point to test. So the origin is x comma y, and that's 0 comma 0. So we're going to put those 2 points into the inequality. So y is 0 greater than or equal to 2 times 0 plus 1. This is eliminated because 2 times 0 is 0. So really we're looking at is 0 greater than or equal to 1. And that is false. So that means the origin is not in the feasible region. So it doesn't work. So we want to shade where the origin is not. So we want to shade on the other side of that red solid line. All right, next one. We have y is less than 3x minus 4. So our y-intercept is negative 4, and our slope is 3. So we start at negative 4, and then we move up 3, forward 1, up 3, forward 1, up 3, forward 1, and then we can make the same kind of movements backwards, down 3 and backward 1. Just plotting points first, and we want to take a look at the symbol. Our symbol is less than, so there's no equal part. So we are going to have a dashed line. So this is actually a point 2, so we dot our line or dash our line, and then we can put arrowheads on the end, and then we have to pick the origin. Again, because it's not on the line, which is really nice. So remember the origin is 0 comma 0. So when we substitute that into the inequality, we end up with 0 is less than 3 times 0 minus 4. This is eliminated because 3 times 0 is 0. So we're looking at is 0 less than negative 4. And again, that is false. So that means the origin is not included in the solution set, so we do not want to shade over the origin. So this side is the feasible region or our solution set. Final example. 3x minus 4y is greater than or equal to 12. This one is presented in standard form, so I'm going to graph the line using the intercepts. So what I want to do is think about the mini equations. I'll have 3x is equal to 12, and I'll have negative 4y is equal to 12, and then solve each of those mini equations. And my intercepts are at positive 4 and negative 3. This one is 4 comma 0. This one is 0 comma negative 3. We have 1, 2, 3, 4 is this one. 1, 2, 3 is this one. And then I can look at the slope is actually positive 3/4. And I can get that from right here, up 3, forward 4. You can get my slope from right there. And then I can plot a couple more points so that I have some just more points to look at. My symbol is greater than or equal to, so I'm looking at a solid line. There's a nice solid line. All right, so we have a nice solid line, and then we want to pick the origin because, once again, it's not included on our line. And, of course, my graph moved, so let me put that back there. All right, so I'm looking at the origin, and if I can go ahead and substitute that in, I have the 0, 0. So 3 times 0 minus 4 times 0, is that greater than or equal to 12? So is 0 greater than or equal to 12? That is false. So that means the origin is not included in the solution set. So I'm going to shade where the origin is not, which is right there.